Welcome to my talk, LiveData, LiveView for JSON endpoints. Now, this might look a little bit like a LiveView talk. It's not a LiveView talk. It's just that the best way to sort of get my idea off in a sort of short title was to compare it to LiveView. So I hope the title wasn't too clickbaity. So most of this talk will be pretty high level. I'll try to sort of get across what I'm trying to do here. But parts of it would also dive more into like some of the technical aspects of the project. So first, a little bit about me. I'm Elias Josephsen, Hansi on most things online. My credentials mainly related to Elixir here, already been introduced, so thanks for that. And I work at a company called PlayPulse, which, although we don't really use any Elixir at my company, they still sponsored my trip here, so thanks to them. So I'm going to start off by just drawing parallels to LiveView again. In LiveView, you write your HTML in your LiveView, and LiveView takes care of sort of synchronizing it to the client, right? The UI you write on the server, LiveView takes care of synchronizing that and making that appear on the client side. And crucially, it takes care of sending minimal diffs, right? So if something changes, it attempts to only send exactly what's changed. So it doesn't send the whole HTML every time. That's the important part. And for those who used it, it feels very, very magical when you use it. So the idea of LiveData maps almost one-to-one onto what LiveView attempts to do, except for like data structures. So the idea is you write your data out on the server, and LiveData takes care of sort of diffing that and sending minimal diffs to the client. And it does quite a cool, a few things that I think are cool to accomplish that in an efficient way. At the core of what LiveData really is it's like a diffing engine, right? You have a data structure, and the purpose of it is to find out what's changed between the last render of that data structure and the current one, and then make the client know about the new state of things with the minimal possible data sent over the wire. But it's also, you also have to be careful about network usage, right? That's the minimizing data sent, but also CPU usage and memory usage on the server. So there are quite a few things we have to keep in mind. That was just a bit of an overview about what the talk is going to be about. But I would like to start by showing you some code just to sort of get you grounded a bit on what I'm talking about. So this was originally meant to be an interactive demo, like do some live coding. But due to some technical stuff, I am doing it with recorded video and some code snippets on the slides instead. So this is the first kind of code I'm going to show you. If you squint a bit and look at this from far away, this looks a lot like a LiveView, right? You have your module there, you use, and then you have a mount, handle info to receive messages, and then a render. But it's not quite a LiveView. At the top there, it's doing use LiveData instead, not LiveView. So obviously something's different. There's a mount. This one is pretty much the same, right? We just create a timer, and we ask it to send a tick message to ourselves after 1 second. And we also assign, in our assigns, a counter to 0. Handle info, no surprise, receives that message from the timer, and increments our counter in the assigns by 1. Then this last one here, the render function, this is where things start looking like very different. So first thing, for those who look closely, is that this is not actually a def like you would normally expect. It's a def-t. This stands for def tracked. So there's a few magic things in there that makes it possible for LiveData to more efficiently track what's going on, what changes between invocations of that function. And that's something I'll get into a bit more later. So inside this function, it's a def-t, it's not a def, but what you write inside it is exactly what you would write in a normal Elixir function. In this case, we just create a map with a counter key to the assigns.counter. And so the idea from the mental model of the user, this thing you write here and render out here, it just gets serialized and synchronized to the server to the client, sorry. But there's quite a lot going on under the hood to minimize what gets sent over the wire. So we don't have to send the full data structure all the time. So this is a really small example, like there's not much going on. It wouldn't make sense to use a LiveData here, but where it really starts to shine is if you have larger things, which I'll get into a bit later. Yeah. So this is some Svelte code, if anyone's heard of that. Yeah, this is just. Yeah, so what we work with here is JSON, not HTML. So what gets synchronized over is a JSON data structure. So it doesn't get rendered directly to the DOM, right? It's more meant for consumption by a client on the other end that you write. There are many different clients available, a couple for now. This is the JavaScript client with a wrapper for Svelte. So the things that are going on here is that there's a LiveData socket component there in your Svelte code. What this does is it connects to the Phoenix channel. It's over Phoenix channels, just like LiveView. It connects to that and then provides that socket to the children. Then below, there's the LiveData component, which then connects to the specific LiveData endpoints using that socket. And you see the path there for the LiveData, which is /simple data. And then how it's done in Svelte when you want a component to assign stuff available for the descendants is you do like a let data equals data. So here we create a variable that's available for what's inside this component. And we just render out to HTML. The counter is data counter. This is a really simple example, but just to sort of get you up to speed on what's going on. Okay, good. So this is a bit smaller than I thought, but it's fine. Yeah, so this is what you see. And not much going on, but what's actually happening here is that the LiveData on the server, it's creating that data structure. It's diffing it and sending it over the wire. The client on the JavaScript side is consuming it, and it's rendering out that counter through Svelte. Let me see if I can skip a bit. So, yeah, this is pretty small, but just to prove to you that there's no, it's not just sending the whole thing. I wouldn't get into it too much, but this is just like the diffing messages that's sent. So it's sending pretty much just the changed value, not like the surrounding parts of the data structure. I'll get into this in a bit and explain why you would want to use this. Yeah, so that was just an overview of the code, or of some code, to get you sort of up to speed on how you would use it in a really, really simple example. But I want to take a step back and look at, like, why are we doing this? Why would you want, what are we trying to accomplish with something like LiveData or something like LiveView? And at the core of it, the objective is to send the least amount of data to the client, right? In the most naive case for LiveView, you could reduce it to just send the whole HTML to the client every time something changes. And that would work. It would behave the same as LiveView does right now. But it's infeasible in practice, right? Because if you were to send the whole thing every time something changes, that's a massive amount of data going over the wire, not really feasible in practice. So we need to do something. We need to do some tricks. And the same thing applies for here. If you have a massive data structure, we don't want to send it over the wire every time. We want to send what changes. And the whole trick here is we want to avoid duplication. If we send something once, we only want to send it at one time. If something changes, don't send anything more than what changes. That's what we're really trying to accomplish. And I want to look a little bit back to LiveView again, because that's what most people are familiar with, and how LiveView does it. So this is just a simple LiveView template, right? There's a div, a title there, where we put in a name from the assigns. There is a status, where we put in the status from the assigns, and like we close the tag, so just like a simple page there. what happens internally in LiveView is it splits it into static fragments and pieces of dynamic data. So the cool part here is that we can send the static fragments only once. We don't need to send it several times. It's fixed, static. But we can send those values that are dynamic every time they change. So we don't need to send the whole thing. And then the client can just reassemble it, right? You can put the name in between the sort of two first top ones, and you can put the status in between the top two bottom ones, and it will assemble it into like a complete string there. So turns out we can do somewhat the same thing, not exactly the same thing, but somewhat the same thing with data structures. And what we can do is, say we have like a data structure that we want to return from a JSON endpoint or something that contains an ID, it contains the name of a user, and it contains the user's current status. The ID, the number itself, that can change. The name of the user, that's dynamic, it changes. And the status, that's dynamic, it changes. But the ID string itself, the name string, the status string, like the keys, the structure of the map, all of that, when you think about it, is the static stuff. It doesn't change for the runtime of the application. So if you think about it, we can really take the map here. We have the ID key, and we can make a slot for the value. We have the name key. We can make a slot for the name. And we have a status key, and we can make a slot for the status. And now we have this thing, which I call a template in LiveData, which is compiled with like a list of dynamic fragments. And if you combine these two, then it will create like the full data structure. And the crucial thing here is that it's just not limited to one map. There can be a map with a key, with a map inside, with a list, with some things, right? You can nest these things arbitrarily. And if there's like if it's a fixed static chunk of data structure, it will only, it will make one template, so you can populate it with data. So this accomplishes a little bit of what we're trying to do, avoid duplication, and it does that by sending the static data only once, right? Our massive response might contain a lot of dynamic data, but it also contains a lot of static data. So we sort of separate the static from the dynamic, and we send them separately. The static gets sent only once. So we gave ourselves a good old check mark, thumbs up. We did this somewhat. So I want to go back to this a little bit again, but I want you to imagine something different. You have the user here, returned in a LiveData endpoint, but the user changes their status. When the user changes their status, we don't necessarily need to send the ID and the name over again, right? We want to send just the status that changed. And for this case, because this list doesn't change order or everything has a fixed position in this list, so what we can really do, we can look at, okay, has the ID changed since last time? No, it hasn't. We don't send it. Has the name changed? No, we don't send it. Has the status changed? Oh, yes, it has. That means we need to send the new one. We need to update it. And this approach is just going through and comparing them and diffing them this way. Works really well for like a static thing. Like it's just a list with fixed items. But it falls down in some cases, and I'll show a bit of that. So this is a bit more of a complicated use case where we have, in our assigns, we have users, and we iterate over the users in the assigns. The assigns could be from a database query, something like that. So the order might be sorted by something in the database query. There might be like an arbitrary order, anything at all. If we were to change, just taking a step back. The first observation I want you to make is that the ID and the name, they're sort of like a static sort of data structure inside there again. Each of these are the same, so we can make a template out of them, and we only need to send that template once. But the list itself of the items, that's more dynamic. We don't know how many times it occurs. We don't know the order of things. We don't know a lot of things. So here we need to do something bit different. So what happens here if, say, the query changes and the 2 items here, those Stian and Heli, they change place in the list. So the most obvious way to do this would be to just send the whole list again. This is something we would like to avoid. If this list becomes massive, we want to send only which changes. We don't want to send the whole thing again. So the thing we really want to send is this item changed position with this item, or this was inserted here, or something like this. But as it turns out, this takes us into really tricky territory really quick. And that's because if you want to diff 2 trees, like 2 tree-like data structures, that's actually a really, really difficult thing to do. The state of the art in like general tree diffing algorithms, if you have one tree, you have another tree, and you want the minimal set of operations to transform one into the other, that's an O(n squared, n cubed operation. So it's not something we can do like in our LiveData. We can't do this to find the diffs. Because think about it, any item in the data structure could potentially move to anywhere else. So if we don't know anything else, we need to sort of compare everything and like look for, has this moved here, has this moved here? It's a really tricky problem. But turns out some other things have encountered this same problem we're having now, and that's React. In order to patch its DOM, it needs to know sort of the identity of elements in its DOM. So if there's a new item inserted in the list, it needs to know, is there a new item inserted between them, or has everything below changed the properties, or what's happened? So what React does, it uses keys, gives you the ability to give this component has this key, and this key identifies this component uniquely. So it gives the framework the ability to track the identity of components. This is the same example from before, and we can actually steal or borrow this exact same approach. Because when you think about it, this inner chunk here, right? This is uniquely identified by the user ID. So if there would be a way we could tell the LiveData framework that this chunk here, it can be keyed by the user ID, that would help us out a bit. So how do we do that for LiveData? There's actually a really simple thing you can insert here. You do keyed, and then user.id, and then you give the inner thing. And this just tells the LiveData framework that I want to give this sort of sub-chunk of the data structure an identity. So now it knows how to track movements of entities across things in lists. So this gives us a much easier time when we want to diff lists and like diff maps with insertions and deletions and things like that. It enables us to do this efficiently and give much better diffs over to the client. Specifically how all of this works is something I want to get into a bit, but yeah. So yeah, this is sort of the view of the framework. It doesn't care about what's inside at all. It just cares about this is the key for those different items, and it uses that to do the diffing. Makes it a lot easier. So this accomplishes is it gives the subtrees in our data structure's identity, which then gives us a much easier time when we want to diff the dynamic parts of the data structure. So another check mark. Yeah. This is just a small aside, but you can have deft calling another deft recursively or however you want. You just need to mark it that this is calling another deft. Yeah. So this is this deft thing is what I've been showing you all this time, but I haven't talked a lot about how it works, and I want to mention that a little bit because I think it's one of the more interesting things of the project. Deft, as I mentioned, actually stands for def tracked, so it defines a tracked function. And it does a couple of things that makes it possible for LiveData to efficiently do what I mentioned just now, what I talked about, to reduce data sent over the wire. For instance, what it does is it walks through the AST of your function, and it performs some transformations on it to extract static parts of what you're constructing and returning. So it does that at compile time. It separates out the static parts of the data structure and then the dynamic ones. And it gives that info to LiveData. It also provides metadata for like whenever you do keyed, right, to give subtrees identity. It does some stuff there. And there are more things it can do in the future, which it's set up to do. And just like def-p or def-n in NX, this is a macro. It's implemented in Elixir itself. Yeah. So what this does internally is it generates a couple of other things. It generates a render function, just a normal function, which performs exactly like you would expect. It just returns the data structure. It also returns it creates a meta function, which returns some metadata about what templates are available in that function. And it creates a render function, which does the actual render, the diff. But this is different than what you would get when calling the normal function. It returns a lot of extra data that LiveData uses to make those efficient diffs. Yeah, so tracked meta, as I mentioned, it just returns metadata about the function. So here's just it returns a list of the templates or a map of the templates that are present in the function. So the implementation can use that later. And you can see in this one, we just create a map with a counter key and then assign it to the assigns. For the template, it's like a make map operation, and then it contains a literal, and then that contains a slot, which is this is where we can insert the dynamic part of the data structure. Yeah. And then the interesting part, I think, is the tracked function itself. What it does is it transforms it into, from how it would be above there, to pulling out the static parts of the data structure and putting the dynamic ones into the list of slots. So at that point, the LiveData runtime implementation can just take those slots and handle those directly. And it knows which template it refers to due to the ID there. But I also want to point out and make sure you know that def-t is not magic. It's something implemented in Elixir. And why this is important is that the def-t compiler needs to be able to understand and introspect the AST of your function in order to function. So as a consequence of this, if you pass higher order functions to and use those inside there, there's a limitation to how much the def-t compiler can support those. It needs to explicitly support higher order functions like those in enum. Everything can still be called, but the output it produces and the diffs it produces to the client might be less efficient if the compiler can't understand it. And I'm a bit short on time, so I'm just going to skip over some of these details. But ask me afterwards if you're curious about this. I think this is really fascinating, and I think it enables you to do some cool things. So let me do this demo quick. In this demo, there is a LiveData on the server. There's a DSL implemented using just normal Elixir macros. And then there's a native app implemented in Flutter. But this native app implemented in Flutter, it doesn't do a whole lot. All it does is it receives a widget tree in the form of JSON. And then it renders that out to native widgets. Right? So on the top here, it's pretty normal. We use LiveData, use Flutter View. In our mount and handle event. Handle event receives events from the client and enables you to update the state from that event. We have a change set in here, right? We're trying to do some form validation, so we use a change set to validate the form on the server. And then the render function is where most things happen. Here you see the def-t render, but we're using a DSL to do a scaffold, which is a widget in Flutter, and app bar, which is a widget in Flutter. We have a form, which is a form widget in Flutter, and we have a column, which is a layout which lays things out in a row, and then a couple of text inputs with some hints and stuff. And they refer to what's in the change set. So yeah, let's change that. It's just a name, email, password, and validates that they're present. And then on the client, we just create a widget registry, which tells us this is the widgets it knows about and can construct from the JSON it receives over the LiveData. And it connects to it, and it does a live native mount. So it mounts a native widget in the application, in the mobile app, according to what it receives over the LiveData. So for the demo, this is what it looks like. So you have this scaffold with a title at the top, and then there's a form with a couple of fields. And then when you enter things in there, it sends the validate event to the server. It gets validates on the server with a change set, and then the annotations with the red get sent back to the client over the live data that this is the error here currently, or there's no error here currently. And that's just a simple example. But you can imagine in the future there could be navigation between different pages. There's a lot more stuff that can be done here. That's just a quick proof of concept. So I'm going to skip this as well because it's not, yeah. And as for potential use cases, there's like three ones I really want to mention. The first one is LiveView-like development of mobile apps, and that's what I just demoed. You can write your mobile UI on the server side, have it render in a native app on the client side as fully native UI. So I think that's a pretty exciting possibility. And this is something built on top of LiveData, right? It's really easy to build on top of. That's really the idea of LiveData. You can build stuff on top of it easily. So easy integration with JavaScript apps. Imagine you have a well-established single-page application already, but you would like some of the advantages of LiveView. So say you have a form which allows you to list all the users that are registered in your application and edit some stuff, like sort it maybe, search for usernames, like an interactive table on the client. You could have the LiveData provide the data and then have the buttons in the browser implemented in your single-page application. Just send events over the LiveData. And then in your single-page application, just render out what you get over the LiveData returned. So you get like 90% of the way to a live view without having to sort of go outside of your normal single-page application that's already well established. And another idea is like more Redux pattern over the network, right? We run reducer, we have a state on the server, and we just do the sort of view part on the client. So those were like 3 potential use cases I could think about. So this is by no means production ready. It's pretty far from production ready. It's something I've been tinkering with for a while, but I'd like to get it out there to hear what you think about it. So obviously getting it to a place where it's more useful for real stuff is a major point of future work. There's some interesting stuff that can be done with tracking dependencies of data within DefT functions that I haven't done yet, but it's possible, which could lead to even more efficient diffs sent over the network. It could support string or binary construction. So right now, it's just like normal data structures, but it could also support constructing strings and like diffing the string construction really efficiently because of the approach we use. Yeah. Other clients, obviously, because right now there's a Dart client and there's a JavaScript client. Writing more clients is actually not a whole lot of work. So the wire format is pretty simple. So that's another point that for future work. And yeah, this is all live on GitHub right now. What I showed off in this talk, it's on my GitHub/live_data if you want to have a look at it. There's some demo stuff in another repo by the side of it. Yeah, thanks.
That was great. Thank you, Hans. So is there any questions? OK, I'll come to you first.
Great talk, thanks. I actually have 2 questions. Like, is there any way to, in the DefT compiler, to, like, for example, give some data and like tell it that this is a static, like, let's say some configuration from runtime EXS, and we know it's not going to change when the application is running. Like, can you enforce it? Do you have such a feature?
So if you could have some configuration that you tell the compiler that this is not going to change. You could do that. You could do like if you do it like an @ like the @ attribute in your module, and then you can like pull in your configuration in the @ attribute. And then if you use that inside your DefT, that would be handled totally static. It would be the same if you would do it in a regular def. That would be a way of doing what you asked, yeah, I think.
Oh, yeah. Yeah, that's possible, but I meant something in runtime EXS, like something that is in runtime, so the module attributes are compile time. likely, but
Yeah.
something in runtime. Like,
So the deft thing, it runs at compile time. So if you want to if you want to get in some configuration there, you would have to do it at compile time to for it to be included in the compiled stuff, if that makes sense.
yeah, that eliminates my second question. Thank you very much.
Thanks.
Any other questions? Oh, OK. I'll ask you while I'm coming across. So there's questions on Hoover. How would it recover from lost messages?
From lost messages. In the same way LiveView does it, it would recognize that the connection has been dropped, and it would reconnect. You would lose, it would reconnect to the server and transmit the full thing over again to resynchronize. I think that was the question. Yeah.
Cool. My question is, like, this seems really similar to LiveView. So I wonder, like, is there anything that's actually shared between those two libraries, or like, is this completely separate implementation from scratch?
Everything here is separate, but that's mainly because it's using like a bit of a different approach than LiveView. So a lot of it is heavily inspired, obviously. And obviously it shares like the channel stuff from Phoenix, and but all the diffing stuff and all that is different.
Cool. Thanks.
There's a few more. There's quite a few questions actually. So how is it compatible with Redux? Not really sure. That it is.
When I say Redux, I mean the Redux pattern.
Right.
With sort of action messages going and then updating the sort of state, and then the state flowing back.
And then another one is, could a client call once and get a full response with a standard HTTP request without attaching to the channel?
That would be possible. There's no, in this proof of concept, there's no explicit support for it. But remember that the def render function can be used exactly like a normal function. So you could totally call that and like construct your response through the sort of same code you're writing for the live data. So there are possibilities there, but it's not something I've done or looked at.
And could, how is it? Sorry, there's loads of them actually. I think you might have to come and have a look in this to answer some of these questions at the end. No, not now. We'll run out of time if we keep going through these. Could the Dart.js LiveView templates be abstracted so you can write once, run anywhere?
You mean the example I gave with the Flutter demo thing? Yeah, you could totally have that whatever you're writing on the server side be platform independent and like be consumed by multiple different clients. What I showed there was specific for Flutter, but that was just like it's a demo. You could do a lot of other interesting stuff as well.
I've got a good one here, which is, how does deft know which parts are static and which are not, which are dynamic?
It looks at the AST of the function, and it what it does is it starts at the return value. It transforms it into sort of a different sort of more data flow representation, starts at the return value, and then sort of walks upward the value dependency chain while sort of keeping track of, okay, this thing is static, we're going to pull this out into a template, this thing is dynamic, so we need to like keep it in the function and put it in the slot. Yeah, it looks at the AST at compile time and determines these things.
Great. Okay, thanks very much, Hans.
Thank you.
It's exciting work. So please, a quick round of applause.